we're going to just review a little bit about how exponents work, and particularly negative exponents, and my favorite, fractional exponents. How you doing, Ms. Stewart?
Great.
That's good. That's good. Fabulous. So this should be very familiar. I have this little fraction here. I have x to the 5th on top, x cubed on the bottom. I want to simplify it. A couple of ways to do it. In my head, I still think about this. I don't know whether you do or not. But I do x to the 5th as x times x. I think I'm going to write this out. X times x times x times x times x. Is that enough?
I think so.
I'm multiplying all those, and then x cubed, of course. X times x times x. Is this going to work for me?
It's going to be beautiful.
I know what x over x is. That's just 1, so I can kind of simplify it by making 1 out of those two x's. 1, 1. And I believe I'm left with 2 x's on top. I'm just going to write that as x squared. Perhaps you remember a shorter way of doing this. I can, of course, just subtract the exponents. So I have x to the 5 minus 3, also known as x squared. Same answer.
Love that.
I guess I love how math works that way. It's amazing. It's amazing. Here we are again. I've switched things around a little bit. This time I've put a bigger value on the bottom. So I have x to the 5th on the bottom, x cubed on top. I like to think of it the same way here. So x cubed, of course, is x times x times x, x to the 5th. 5 x's. Again, I know x over x is 1, 1, 1, 1. Now I'm left with 1 over x squared. Well, that's interesting. I wonder if I can do my same subtraction do. What do you think, Stuart?
I think you can.
Yeah, well, math is pretty good that way. So this is really the same thing as saying x cubed, x to the 3rd, minus 5. Well, that gives me x to the negative 2.
How kooky.
So what do you think that means, Ms. Stewart?
Well, those must be equivalent.
That's right. Yes, now I remember that. So in other words, if I have something in the denominator, like this x here, if I have an exponent in the denominator and I want to move it up to the numerator, what do you think, Ms. Stewart? How do I do that?
Well, that's the same as x to the negative 2.
You betcha. So all you really have to think about is when you move something from the bottom to the top, all you really have to do is change the sign of the exponent. And I think it makes sense why that must be the case. What do you think, Ms. Stewart?
I agree.
We're going to be doing some interesting derivatives with these exponents. So it's important that we can just rewrite these expressions in different ways. Let's start by rewriting each of these expressions only with positive exponents. We have 3 over x to the negative 4. Well, if you remember what Mr. Haas was just talking about, that x to the negative 4 really means I have the x times x times x times x times x, but where is it really? In the numerator. In other words, if I want to move that from downstairs to upstairs, I simply need to change the sign. 2x to the negative 2 over 5. Well, if I want to rewrite this with only positive exponents, that 2 and that 5 are just hanging out. That x to that negative 2 is the only negative exponent. If I want to rewrite it with positive exponents, I'm going to bring it down into the denominator, x squared. So these are equivalent expressions. All right, let's see. Where is that x to the negative 6? Is that in the numerator or the denominator? Well, if it helps to remind you, remember you can always think of that x to the negative 6 over 1. Really, that's the same as x to the negative 6 over 3, right? If I want to rewrite this expression so that I have only positive exponents, I'm going to have to move that little guy down into the denominator. So I have 3 times x to the 6th, leaving a 1 in the numerator. So again, you might be asking, well, why are we doing this? You'll find out why when we start doing derivatives.
I want to do 2 more real quick here, if you don't mind. This is a little bit different. This is 8x to the negative 2. And you have to remember that this time it's not just the x being raised to the negative 2. The whole thing there, 8x, is all being raised to the negative 2. parentheses matter. You know, I always say that, Stuart.
I do too.
They always matter. So first I'm just going to write this as 1 over 8x to the positive 2, right? I just change it from negative to positive. Remember, this is really all over 1 to begin with. And now, again, this entire quantity here, 8x, is squared, so I know what that means. It's 8x times 8x, and I'm pretty sure that's the same thing as, what's 8 times 8? 64, x times x, x squared. There you have it. We have one more over here. A fractional exponent. And you know, sometimes students get negative exponents and fractional exponents mixed up, but really there's no need to. All I need to realize is that I have something raised to a negative. I want to change it into a positive. Okay, I want to put this whole thing as over 1. How do I change x to the negative half into a positive? I just bring it downstairs. So I'm just going to rewrite this as negative 4. The x goes downstairs. Along with that exponent, instead of negative 1/2, it's positive 1/2. That's the whole deal.
Let's try to go the other way now. Now our mission is to rewrite each expression so that I'm using negative exponents. And again, you'll see why we're doing this. Right now we're just practicing so we feel comfortable. If I want to rewrite this expression so that my x is raised to a negative exponent, again, that involves my moving my x to the negative 1/3 up to the numerator. That 6/5 is not affected at all. It's just chilling, to use the common
Yeah, very nice.
term.
That's what the kids say.
I didn't really pull it off very well.
no.
But anyway, that x coming up into the numerator, then you have to have the negative exponent, and there you have an equivalent expression. If I want to rewrite this with negative exponents, that x to the 3rd needs to come downstairs if I want to write it with a negative exponent. Ooh, this is kind of fun. This has a little invisible exponent of 1. If I want to rewrite this with negative exponents, I'm going to be moving that into the numerator. And there you have it. One thing just to also note, I could have written this one a different way, right? I could also have expressed that as 6/5 times x to the negative 1/3. Those are both ways to write this expression using a negative exponent.